Hi everyone, and welcome to the second talk for Detour Ahead. Paul, I spoke to Paul a little while ago, and sort of after his great recommendations at last Detour Ahead and excellent speakers, and he had put together a list, and top of that list was Adriana, who's joining us from Germany. But Paul, you obviously know Adriana, so maybe you could do a quick introduction and
good morning, Adriana. We met when I was doing a course called FAB Academy. Adriana was my tutor on this course, and it uses it's a course which sort of uses a lot of the machines that we've got here in the lab, so like our 3D printers, our laser cutters, also some of the more kind of mechatronics, so electronic components and sensors. So I'm going to let Adriana introduce herself, because I know she covers a lot of bases and works on quite a lot of different projects. I'll pass over to you, Adriana.
Yes, thank you, Paul, and thank you for this invitation to be here in the Roadmap for Creative Industries in the Detour Ahead event. As Paul says, I am Adriana Cabrera. I am also teaching in different courses in Hochschule Rheinbad. It means in a university here at FAB Lab Camp Lindford. But at the same time, I am senior consultant in Matrix, located in Düsseldorf. So, and one of the projects that I am doing with Matrix is this big project. The name is SheMakes. SheMakes is a project, a European project with 6 labs, as the lab that you have in your university, and we are empowering future female innovators to sustainable fashion industry through inspiration, skills, and networks. And the idea is to really through science, through STEAM, and through skills that we learn in the labs, really create and look for alternatives in sustainable fashion and textile practices. So, and what I was thinking is that today I will talk a little bit about my experience also is as a student. I study here in Germany. I study media art and design. And after I study textile and surface design with focusing in material research, and I wanted just to share a little bit some projects around around what I did as a student, and also what that helped me to understand what I wanted to do in future and what I am doing today. So this project, the name in German, Licht und Klang in Medium Pavilion, that is light and sound. And this project was inspired by the jubileum, the 100 years from the live from Oscar Sala. And here what we see is the construction of this pavilion that we did in collaboration with the media architecture department at the Bauhaus University. And I wanted just to share a little bit of the experience what we did. As I said, I maybe that was the first project I did in the university. It was super challenging, but at the same time, it's not only the work of me, myself, of course, it's a work for many professors and students, as I said, in collaboration in an interdisciplinary group, what we did for this collaboration for an installation of a pavilion.
Once upon a time, when I was sitting inside a black box, where a little hole cut through the front wall was the only source of light and exterior sound, I realized the power of my finger. I realized the power of a small gesture. I realized the power of me. But I also had the feeling that there must be a way to achieve the same enormous effect as a result of this little gesture by using a more complicated and complex system than sunlight, a box, and a hole. Instead of a box, there could be a huge architectural construction built upon abandoned waste ground. We would call it the pavilion. Instead of the sun, we could use the immense and magical power of 40 cold white neons mounted upon the inner walls of the pavilion. Instead of the resonances of urban ambience, we could use a quadraphonic and generative sound system consisting of various analog synthesizer modules. Instead of a hand, we could use our whole body to control the highly interactive light and sound environment, thus merging with the complex audiovisual surroundings, hypersensitizing our sense of sight and hearing, becoming something bigger.
And just to reduce a little bit the story, what happened in this pavilion, or what it tells a little bit more about what we did with the synthesizers in that time. From Oscar Sala, he just used analog synthesizers to produce sounds, and what we tried to do with my colleagues or with my fellows was just to try to synchronize the lights with the synthesizers and make kind of a projection mapping in this pavilion. And yeah, as I said, it was a really interesting story behind, because although of course I was not like a programmer, but we couldn't also play with several instruments and have like a first approaches with electronic, Arduino, and circuits. So and also the topic about pavilion was also for me a very interesting one, also to understand structures and understand this tangibility with electronics. So one of the other projects that I like a lot, and also it was like trigger my passion about movement, was this project that I developed with my colleague Diana Cano, making a kind of a small model for a pavilion with the same inspiration of interactive pavilions, but this time a pavilion that could move. It means that the user could be maybe close to them, and also the pavilion could start to move and to recreate this closing or opening, and also what we call this labyrinth. And what we did with this was to use a smart material. The name is Smart Memory Alloys, to create these kind of movements. And yeah, that's some of the stories when I was studying, and after I had the opportunity to come to Camp Linford in the University of Applied Science Rheinbach, in which I have like a big a new experience, like a little bit different, but I came with industrial design background, with this artist, let's say, also background in my studies in the master, and after I wanted to explore a lot of those. Therefore, I came with this big challenge that it was create or build a lab with 600 square meters in this empty space that now looks like a little bit like this that we have here. And we didn't create this alone. It was also with Luis Bueno, that maybe you will know after. We have this challenge, and it was very tough for me. We were doing also workshops with RepRaps, building by ourselves 3D printers with schools, in order that the schools could also have like a 3D printer in the classroom, and learning a lot about machines. And but at the end, I start to do also courses as the FAB Academy, one of the courses from the FAB Foundation, that it's you learn how to build almost anything. And in this course, I choose a topic like how, okay, I have a lot of machines, but I want to use these machines for a real purpose that I could have, like, let's say, a local impact. And in that time, I knew a patient who had paralysis in his left hand, and I started to do a process and create like that time I wanted to do something interactive with soft surfaces, but I just started to create this assistive device for Frank, and the idea of this device was to help him to stabilize the hand and to move the fingers. So of course I didn't do this alone. I just had help of a physiotherapist who helped me to understand a little bit more of the illness and understand a little bit about the biomechanical aspects and challenges around the body. And yes, that was my first approach in assistive devices, and this helped me a lot to inspire also new courses and inspire also students in the lab, in which we did several activities, for example, the help camps, the accessathon, and through this experience, we want also or it creates some ideas that won a challenge in Google, the Google challenge in 2018 for create a new platform for exchange in between makers and physiotherapists and patients that needs also such a help. So, and what I and maybe in this whole process, what I find is that really in this intersection from product development and in order to innovate, maybe I am working more in the prototype phase more than a final product, but it's a very important part is that we need really the intersection of design, art, science, and technology, and actually the role of you as students to don't forget that this intersection and explore this collaborating with other professionals. It's very important, and also to understand that maybe when I studied industrial design, we were not let's say focused on the physical aspects, but let's say at all, like when I was looking for a job, they were really like more focused on the visual aspects. But we start to understand like, no, wait, for product development we need to understand a little bit more other aspects that we need to develop, as for example the soft materials, the intelligence, the microstructures, other kind of interactions that we can create with pneumatics and this functional and emotional aspects that we are communicating through this. So I start to look more deeply about soft robotics, and it's a field that it's more and more explored this in the last 5 years. And soft robotics is about this, they use the creation of robotics that are made for or by inspired, let's say, by organic systems, and therefore wearable applications is step by step more explored by the field of soft robotics. So and we understand, as I said, that this ecosystem is not only made in digital fabrication, but also textile crafts or interaction design, media arts play a very important role in developing such devices. But by the same time, also understand material, that material can also drive innovation. So that the social and technical aspects of the materials also bring a very important part in the products and in the prototypes. And I just always like such a build that is a bamboos. And when we think about, for example, 3D printing, in which we are just programming an infill, and we think like, that's kind of a new stuff. But when we see in nature, as for example, this piece in bamboos, that we see how nature could be intelligent to create this kind of infills in order to create a very stable structure. So, and how, for example, we can replicate and extrapolate such properties or kind of features in order to base this in our designs. So one of the practices that we start to make also in cooperation with other labs was this project that is the BioShades project with the Bach Textile Lab in Amsterdam, in which we start to understand how we could dye our textiles with bacteria. And another part is that we could understand also with the tools that we have at lab the structures, so at all, and how we could play with these materials and the structure, and feel like how we could perform several, how we could play with the materials, so like in order to create these structures that we see in nature, and how we could perform new structures, as for example, it's making the 3D knitting in Nike, and how what we also try to do was to understand like the technologies, as for example 3D knitting here in Germany, in which we developed also a course in which we try to understand also these 3D knittings and these concepts, and how we could apply also for assistive systems. So it means that, yeah, now this CAD manufacturing also can help us to customize our wearable technology, and also, for example, to create soft electronics that, for example, that we can also find new ways to embed our our electronics or systems that we are doing. So that was some of the continuation of this my orthotics. I tried to continue my project to do this available to understand, and also, for example, if in the past a piece of 3D printed takes like 12 hours, in this version I transformed this in a surface in which, for example, with the laser cutting, I could cut this in 12 minutes. So, and these are the possibilities that we can explore also through digital fabrication, and also to explore more aesthetic components and aesthetic features in our devices. So so for example, this is one of the projects from my students, in which we try, for example, to do an insole for patients with diabetes, in order to measure, for example, the weight of the body, and understanding, for example, if something that it's not created at all, and this is something that help us through the digital fabrication, that we can create things that are still not available on the market. Exactly. So, and for now, as I said, I start to explore the field of soft robotics, and I start also to teach the lecture of soft robotics in one of the academies, as Paul says, the FAB Academy, in which we explore structures from inflatables, mainly performed through pneumatics and hydraulics, that which help let's say, to adapt to the form of the body. And for example, this is a project from one also of the students from Camp Linford. She developed like kind of a interactive costume that could mimic the animal reactions in terms of fear and breathe with a galvanic skin sensor. Elsin developed this in 2017 in Camp Linford, and it was one of the first, like, let's say, inflatables that we developed in the Fabric. And these are a project, soft skeletons, one of the last projects that I developed with the University of Arts of London, with the College of Fashion, in a project, the name is Bio-Inspired Textiles. And this project is about the inspiration of how the tissues in an elephant trunk are distributed, and are how these the fibers arrangements are located, and how because the elephant trunk has as we know, they don't have like a skeleton. It is performed by different fluidics, and how this let's say the elephant trunk distribute, let's say, the forces in these tissues is the form how it can perform a lot of movements. And this is what I did in this small research, and I will just show you one of the videos that I have for you, so that you can a little bit understand the concept.
Soft Skeletons is a project inspired by the gradient structure in biology, and with a focus on impressive dexterity of the elephant trunk. This property is named in biology as hydrostatic skeletons, where the force is transmitted not through rigid skeletal elements, but instead by internal pressure. The walls of many hydrostatic skeletons are reinforced with different layers of connective tissue fibers that control and enable shape change. I based this model in the orientation of three types of fibers: the longitudinal, the orthogonal, and the cross-fiber helical, understanding the movement individually in the units and in the arrays. The length is controlled by longitudinal fibers, providing support and rigidity to the structure. The cross-sectional area can be controlled by fibers oriented circumferentially, radially, and transversally. Fibers in this orientation are important for elongation. This orientation also supports bending movements through selective contraction. Helical arrangement fibers create torsion or twist around the long axis. In this case, the chambers distributed in both right and left handle helical layers are typically presented and create torsion in either direction. By using rapid prototype, this model is built with low tech to quickly produce and transfer the information of the biological principle to design of a proof of concept of a soft actuator. This prototype is made by a composite of 6 layers of thermoplastic polyurethane. It is sensible to heat, and it's good material for prototyping and crafting, enabling the design of prototyping of the air chambers in 4 layers and the different angles. An extra layer of fabric is added to reinforce the structure in this version. This material is 30% structural in both directions to limit the shape change. Soft skeletons could be used as a shape-changing and programmable material. It could be adapted in various applications such as assistive systems, therapy, or other applications in the area of biomechanics, movements, and interaction. Building structures inspired by hydrostatic skeletons can have an excellent dexterity and strength through configuration and control of fibers. In this case, these structures can provide high efficiency in their performance, have a long duration, modularization, and even recover themselves. This is what I want to explore with soft skeletons, showing an approach of emerging materials that can offer a novel soft actuator with a sustainable system.
Oops. Okay, just give me a second. Yeah. So now, yeah. So that was like one of the one of the projects, like the last one, the soft skeletons that I really try to apply. Let's say by inspired design or by being informed by nature, to extrapolate these concepts to soft robotics, and actually what we see, maybe it's one of the applications that I had in mind, but basically what we can also really explore with one piece of this concept is something that we can afterwards like really expand in each direction, not only for product design but also for other fields. Yeah, now I will just have like a little bit of change, and this project that I will present now is Sense of Nature. Is a project, is let's say one of the collaborations that I'm working now with two with Moon Rivas. She's a dancer, but also cyborg. It means she had an implant in her body in the last time, and I will just show you a little bit about what we did through this process of making something and a collaboration in soft robotics, but with an artist.
My name is Moon Rivas. I'm a cyborg artist and choreographer, and for almost 7 years I've had implants in my body that allow me to feel the seismic activity of the planet through vibrations. A couple of years ago, I took my implants out, but I still want to perform the piece where Earth is a choreographer and it reacts when I'm on a stage. And then this idea came to me. To create a piece of garment that it will function like the implants did, and in the same time, people could visualize in a more direct way how the Earth moves.
Oh, okay. I can. The video is a little bit longer, but no worries. I will just tell you a little bit about the concept. So we start to do a concept in which Moon in that time she wanted to really try to explore and let's say with explore another ways to feel the earth, and at the same time to communicate this with the audience, and therefore she look in the soft robotics a way to express this concept. And this is some of the exploration that we did also together with Montserrat Sigues. She did also the FAB Academy, and we start to create like a concept for a new, let's say, garment. And what it was also important in this part was to understand the connectivity, because let's say the input of our dress was the air. It means that we had to connect via like wireless to air quake station to get the data and connect this and trigger our soft robotics. So and another part that was of the important part was to understand how to design our garment, in which we use also tools as, for example, rhinoceros, Maya, and and also to have like the aesthetic of the dress based on the body of Moon, because we did this in pandemic time. It means that I didn't have contact with her. I had to have like 2 arrangements also with the 3D scanning to scan the body, and based on it adapt let's say the design in the shape of her, and of course understand how I could send, for example, the data and make several simulations to actuate my small pumps. And yeah, another important part was the simulation, because as I said, through Corona time, we couldn't really, we needed to see how maybe it would appear or function our soft robotics. And of course, it was also very interesting part, because actually what we had and after the scale was also a very important part that we wanted after was to improve. So and that was the result that we have. I will just show you some of the video of the performance that she did. Yeah. Okay, so that's actually the last project that I have for you. I am very happy to open this time for questions. I think that it's a lot of some projects and information, and I would be happy to hear a little bit about your questions or suggestions. And yeah, as I said, thank you for this invitation.
Thank you very much, Adriana. That was, it is really nice, and really nice to see some of the projects that you've been, I think I knew you were working on that project when when we met. So yeah, it's nice to see those kind of come to fruition, like being fulfilled, that one where it's sort of looking at the earth. I guess just sort of looking at the chat, I think sort of a really nice comment that Shri made was just showing the really nice link between design, nature, technology, and the science, and just how it's working all together. And I know here we're sort of looking a lot more at like sort of STEAM technologies as well. So yeah, I think it's been a really nice STEAM learning. So combining science, technology, arts, and maths as well to sort of to have a bigger outcome, kind of bigger than its individual parts. I've not got too many questions directly from the chat for you, but I guess one thing would be interesting to hear from you is how did you find like interacting with people from different disciplines, like making those connections? Do you have any sort of advice on how to go about making those at all? Or how you went about sort of making those connections with different people, different industries?
Yeah. Actually, I forgot some one slide, the last one, but I think that especially in the context of the Fab Labs, so we have the possibility to interact with other disciplines, especially I guess that in your, I don't know, in Camplin for the lab was open for all studies, let's say, all faculties. I think that that was the one important parts for me to understand, and also the interdisciplinary projects that also the university in that time offered. So, and today I guess that because we had the two academies, so the basically through the FAB Academy and FAB Academy, there are like academies that you can also apply, not only, let's say, designers, but also people from other disciplines. So I think that that was one of the important parts. Also, especially, let's say, about the FAB Academy, as I mentioned you, that I was interested in assistive devices, but I didn't have really background in, let's say, physiotherapy or something like this. What I tried to do was to contact some physiotherapists interested in, I present my project. So I think that this is from, like, let's say, two parts. One is that what it's possible, let's say, in your environment, but the second part that it's also even maybe important is that if you are interested in a field, I think that it's very important that you take the initiative and go and ask. And I think that in mostly times you have always a good perspective, you know, so like that people want to help, or said like, yeah, maybe I can help or not, or at least to give you an advice. And I think that this now it's a very important point to just take the initiative and don't be afraid that if you don't know a lot about the concept. I think that in any case, like, people would be happy to help. That's my advice.
Oh, that's nice. And yeah, I guess it's worth saying to sort of everyone listening, like, we are completely open. You know, we work with engineers, we work with artists, architects, fashion, textiles. We work with like a lot of disciplines that we have at this university. So a lot of it's about coming to the space. So I guess how I've understood the whole FAB Academy network, it's a very global network, but it's these kind of local interactions which really matter. So I guess the main thing I'm saying is don't wait for a workshop or, you know, you to be led to us. We're always here. We're always open. And we'd love to see you. And I think it's, yeah, for us, for myself, we've got a new technician starting soon who's worked in a very similar environment to Adriana and myself. So yeah, we're very keen on sort of facilitating these kind of interactions as well. So definitely do come along. There were a few kind of more specific questions in the chat. So there was one from Beverly Coldron, and she was asking, like, could you make aids for someone with osteoarthritis of the knee and soft tissue damage? And that's to try and help the muscles which are weaker to get stronger again if the muscles are kind of damaged. So I guess it's sort of using the soft robotic technology in a kind of physiotherapy setting. Yeah, I mean, I
see. Sorry, because I was looking the comments. Yeah. But I think that I mean, let's say that all I have to say that in assistive devices, all, let's say, cases are kind of different one with different even, for example, for paralysis with spasticity had some requirements. With the, I mean, there are many requirements, but at itself, let's say that there are many opportunities to intervene with wearables. So therefore, and as I said, that soft robotics is taking a lot of these resources to explore this more in the fields of rehabilitation, in medicine. So I didn't work directly with osteoarthritis, but I know that there are many people working in that field, for example, with electrostimulation or even with inflatables in the hand. So I didn't do personally, but I know some projects about it. If you are interested in the Beverly Cole, maybe you can help it.
Beverly, yes. Beverly.
And yes, so another suggestion maybe is that we have there is all the enable community that it's also it has a good let's say repository or documentation of, for example, development of prosthetics. They did a very nice the enabling future was a really nice community that started this kind of work. Another project here in Europe is the Carables that actually finished in the last year, but we start with the FAB community. Maybe I will just type the website, FAB Care, in which we are trying to join and work with people who has such an interest to work in assistive devices. I can put this in the chat, I guess, no? The name is fabcare.network, the website.
Thank you. Yeah, I mean, I think I don't think anyone can argue that a lot of the pieces you've shown are really beautiful. You had really beautiful outcomes, but I think it's quite nice the kind of a lot of them are sort of very personal, like centered on the person that you're developing for. And I guess it's sort of maybe it's a different way to how a lot of the thinking is that well, it's not necessarily the case, but I guess there's sort of different ways of interacting with yourself. And I think that's another thing that people can take away from this. Different ways of interacting with yourself and interacting with the environment, and kind of what impact, how you can show that in a very aesthetic way is really nice as well.
I think that the creative part is very, very important. And even, for example, now in Corona, that we see that many people are at home, that maybe you don't have really, like you are so much focusing your things. And I think that the emotional part, it plays a very important role. And for example, the time that I start to design this, I was looking really just basics. I was looking like really horrible devices that I was thinking like, now that would be a really, like, imagine a kid with this device in the school, and after maybe everyone will say like, oh my gosh, no, it's like, like it will be a part of the group, but at the same time there are, for example, another Fab Lab, for example, in Colombia, that they are making prosthetics with like kind of with superpowers, no? As for example, that you can make this with an aesthetic of Superman or something like this, and that the kids feel like really encouraged to use, and that feels special. And I think that in that kind of in that kind of process in the disability, and for people with disabilities, is so much important. This emotional aspect, and feel like that it brings like kind of a confidence. Even also for people with arthritis or tremor, that, for example, in the cases of a meeting, people think that they are drunk or something like this, and no, it's actually they have a problem, but therefore they feel more unsure of, for example, drinking something. And in that cases, you think, as a designer, I can do something. I can really say like maybe because there is some device that I can design, or maybe just even change the color of your device will change something. And I think that we have plenty of space as designers and as our artists also to help in that cases. So yeah, therefore that's my, I hope that brings you something that motivates you maybe to go in that direction. And yeah.
No, definitely. Yeah, it's kind of the importance, right? You don't want to wear something that's that you're not comfortable wearing, really, is it?
Yes. So I just wanted to before I forgot, put a little bit of advertisement for FAB Academy. There is a program that Paul was part of it. Did amazing also projects, and not only FAB Academy, the FAB Academy are two programs for the FAB Foundation that also accompany also like kind of your studies, and also can also push a little bit forward these kind of interactions in between different disciplines. Yeah, but also of course you can contact me if you have some questions. Yeah, be happy to. I am here to hear about it.
Thank you very much. Yeah, I think another kind of, I just sort of want to say another takeaway that I felt from this is, and something that we've started doing here quite a bit is, I guess a lot of your work, it was sort of creating new materials with new properties as well. So I think that's really kind of interesting. Like, it's not limited to just what's around you. It's like, what can you actually create with the properties that you want? So I know our textiles lab, for instance, is doing a lot with biomaterials at the moment. I think the soft robotics is really interesting because it's adding a whole new level of, yeah, it's giving like, yeah, something very flat, very kind of ordinary, but it's giving it completely different properties. So yeah, please come and have these conversations with us. We want to sort of push all this stuff ourselves, but it'll be great to see, you know, the students, you all developing this, because we have these technologies, we have people here willing to help you and facilitate it. So come and bring us your ideas. We'd really like that. So yeah, thank you very much, Adriana.
Thank you, Paul. As I said, that's this is the website, the fabcare.network, in which we could also find, it is also a really take action. It means how you can get involved, and toolbox in which you can also find some tools to develop to start to work in assistive devices from, let's say, the very beginning. Is something that developed also Open Dot Fab Lab in Milano, and also Fab Lab Campifer with me. So yeah, thank you so much for this invitation. Yeah, I hope to hear from you.
Brilliant. Thanks, Adriana. That was great, you and Paul. Some great comments there from the students. So yeah, just to remind everyone that the next talk is at 2:30, and you can find that on YouTube and the links I posted. But yeah, once again, thanks, Adriana. It was really insightful, and I think we even get a message from the new technician, Lewis, halfway through as well.
Yes,
so
so yeah.
Yeah, big thumbs up from you guys. So yeah, yet another kind of yeah, discovery of interconnected kind of creatives, which I talked about in the previous talk. But yeah, no, thanks again. That was really really great, and really lively comments from the students. So brilliant. Thanks everyone. We'll see you soon.
Thank you.
Thank you. Bye.
Bye.
Okay.